All right, so to start off here, we have 2 warm-up questions. This is going to be based off your direct and inverse questions yesterday. So some things I noticed is that there's the inverse word right there. So the current is inversely proportional to the resistance. So I'm going to label the current as C and the resistance as R. So I'm going to say that our current is proportional to some constant divided by the resistance. And then they gave me some data to help me figure out the constant. So I know that if my current is 5 amps, the resistance is 24 ohms. So I'm going to do 5 times 24 in order to find my constant. So that means my constant is 120. Now I'm changing the current to 7, and I don't know the resistance. Remember, if something is in the denominator and it's set equal to a constant, I can swap these because I would be multiplying by R and then dividing by 7. So really I'm doing 120 divided by 7. So the resistance would be 17.14 ohms, and I'm just going to draw the symbol because I'm not trying to squeeze words in there. This next question is about sales tax. And sales tax we know is direct because if the purchase value goes up, the tax also has to go up. The purchase value goes down, the tax would go down. So I know that's direct. So I know that my tax is equal to my purchase price times whatever my constant is. So my purchase price was 60, and that ended up making $3.90 for tax. So I'm going to do 390 divided by 60. So that tells me my K value is 0.065. So what this actually means, just so you understand the real world scenario of this, if I move the decimal twice, it would be 6.5. So this is telling me that my tax rate is 6.5% of whatever my purchase price would be. Anywho, so trying to find my tax for a $400 purchase. So I'm going to do 0.065 times 400. So that tells me my tax would be $26. Next little challenge question we've got for you here is a little bit different because now it says it's inversely proportional to the square. So I'm going to label intensity as I. I'm going to label the distance as D. So the intensity is inversely proportional to the square of the distance. So that means distance squared. So the light hangs 4.8 feet above the center of a circular table. All right, so my suggestion, especially in a question like this, is to draw yourself a table. I mean, a picture of the table. Just pretend that that made sense. So here's my table. We'll just pretend. Lovely table. And here is my light source. Okay. So the diameter of the table is 7.2 feet. So this tells me that the radius here of the table is 3.6 feet. And I am going to need that. Hate to break it to you. So this point right here, I know that intensity. So here, this is 4.8 feet. And I know the intensity of the point right below the lamp. So that would be an intensity of 24 lux is my constant that I don't know yet, divided by 4.8, the quantity or the value squared. So I'm going to square 4.8, which gives me 32, excuse me, I can read. Oy vey, 23.04. And then I'm going to multiply that by 24. So my constant is 552.96. Okay. Now here comes the crummy part. This is the distance from the light to this point right here on the edge. This is the point that they want us to find. Okay. I don't know this straight line distance, so I have to use Pythagorean theorem. So let me get out my handy dandy calculator. So I'm going to do 4.8 squared. Oop, nope. 4.8 squared plus 3.6 squared, which, oh my gosh, gives me 36. How beautiful is that? So I know that c squared is 36. The square root of 36 is 6. So I know that that is 6 feet. So I'm going to take my constant and divide it by 6 squared, and that will tell me my intensity at the edge of the table. So 552.96 divided by 36 gives me a lux measurement of 15.36. I know that one was a little cray. Hopefully it wasn't too scary. So today we're actually going to talk about combined variation. This is actually when something is direct and inverse relationships happening at the same time. So that means I've got something chilling in the numerator and in the denominator. I still have K as my constant of proportionality. That hasn't changed. I've just kind of smashed the direct and inverse equations together. So I have a couple examples that we're going to do together. I think I have 5 examples for this, and we're going to look at what this actually does. Okay, so y varies directly with x and inversely with z. So this is actually going to look exactly like that equation I just gave you. Direct with x, inverse with z. Now here you'll notice I have an x, y, and z value. That's to find my constant. So I've got y being 24, x being 48, z being 4. So personally, I would simplify 48 divided by 4 first. So 24 is k times 48 divided by 4 is 12. So in order for 24 to equal something times 12, I know my constant has to be 2. So now my job is to find x. I know y is 44. I know my constant is 2. I don't know x. And I know that z is 6. So you can do this a lot of different ways. You can do 44 times 6 and then divide that all by 2. You can simplify 2 divided by 6 and deal with that. Personally, I would do, since I have a calculator, I would do 44 times 6 divided by 2, which gives me 132. All right. Another one that's got a square in it. Stretch of a wire. So I'm just going to start labeling stuff as I go. So the stretch under a given tension, so S is going to be stretch, directly with length and inversely with the square of the diameter. So L is length, S is stretch, D is diameter. So the stretch varies directly with length and inversely with the square of the diameter. All right, so I have a wire with a length of 2 meters. So I'm going to start substituting stuff in where it goes. So it's got a length of 2 meters, a diameter of 1.5, and a stretch of 1.2. So I'm going to show you exactly what I would do. This is the Scientific Desmos calculator app. So I'm going to do 1.2 times 1.5 squared. So that gives me 2.7. Now, unfortunately, I didn't do this very smart. I should have made it a fraction, but I'm going to clear that. So I remember that was 2.7. So now I'm going to do 2.7 divided by 2. So the first thing I did was I multiplied by 1.5 squared. So I did 1.2 times 1.5 squared, and that was 2 times k. Oh, sorry, you can't see that, can you? And then I'm going to divide by 2, and that would give me k. So my constant is 1.35, okay? So now I'm going to find the stretch when I know the length and the diameter. So the length is 3 meters, the diameter is 2 meters, millimeters. I can read, I swear. All right, so if you're using the Desmos app, I'm going to go ahead and hit the fraction button first. Then I'm going to do 1.35 times 3 in the numerator and 2 squared in the denominator. So the stretch would be 1.0125, and you can round that if you want to. If this was a test question or a quiz question, we would tell you what to round it to. And let's see, the stretch is measured in millimeters. So that would be my final answer. All right. Number 3 is actually almost identical to number 2. So I'm going to skip it and I'm going to go to number 4. Oh, that's a lie because number 5 is identical. So let's do 3. Just kidding. All right. So very similar to the one we just did. Teensy bit different. All right. So conductance varies directly now with the square of the diameter and inversely with the length. So now the squared thing is up in the numerator. So the conductance is K times D squared divided by L. So it's a little bit different than the stretch. So my first one, 50 meters of wire, that's a length measurement. So that's going to be my denominator. I don't know K. That's what I'm trying to find. With a diameter of 2 millimeters, has a conductance of 0.12. So what I'm going to do is I'm going to multiply by 50 first. So I've got 0.12 times 50. Oops, not 5, 50. And that would be equal to K times 2 squared. So then I'm going to have to divide that by 2 squared. So this is my fraction. 0.12 times 50 divided by 4. So my constant is 1.5. So now I can go ahead and use this other information. Wire of the same material has a length of 75 meters. I know my constant now, and it has a diameter of 2.5 millimeters, and I need to find the conductance. So I'm actually just going to put that straight into my calculator as it is. So I've got 1.5 times 2.5 squared divided by 75. So the conductance here would be 0.125, and the units all right. So not that much different than the last one, just the fraction got flipped around a little bit, but very similar again. Now, last but not least, we've got a team of 6 painters. They're doing a room. It's 2,400 square feet, and they painted, or excuse me, they're doing a home. They took care of that home in 8 days. So the time that it takes varies directly with the area and inversely with the number of men. That should say of, not or. Hired for the job. So a team of, let's see, the time, I don't know the constant, directly with the area and inversely with the number of men hired. So 8 days was my time. The area was 2,400 square feet, and it was 6 painters. So here I'm going to do 8 multiplied by 6 divided by 2,400. So 8 times 6 divided by 2,400. So my constant is 0.02. So now I'm increasing it to 8 men for 4,800 square feet, and our goal is to find the time. So I've just substituted in 8 men and 4,800 square feet. 0.02 times 4,800 square feet divided by 8 men gives us 12 days that it would take.